Okay, it's going to be part 4 of chapter 15. So this problem, we have both 6-inch radius wheels roll without slipping on a horizontal surface. This is the little diagram of it. Only the distance AD is 5 inches. That's AD. The distance BE is 4. BE is 4. And D has a velocity of 6 inches per second to the right. Determine the velocity at point E. This is point P, this is point Q, it's point where velocity is 0. So, what do we know? You know, velocity of D, that's given, that's 6 inches per second. We know the velocity of D has essentially a component of velocity of P, the velocity of D2P. So, set that out. We know the velocity of P, there's 0 slip, so that's 0. So, the velocity of D is equal to the velocity of D2P. Now, the velocity at D2P is equal to the angular velocity of dk times or cross with the radius in the j direction, which is 6. So we're going to have omega k cross negative r d to p j, and that gives us 6 omega I. Now we sub in for the d2p, we know that's the same as velocity of d, so that's 6. And we have this term here, which we just derived. So we solve for the angular velocity, which is 1 radian per second. So, great, we have that. Now we can go here. Now we know that, again, the goal is the velocity of point A. So first we're doing is going from here, getting the velocity here, getting the velocity here, and then getting the velocity here. And what we'll do is we'll have this equation, velocity here, and solve from this direction, and then solve from this direction, and then just solve for unknown terms. So, velocity of A is equal to velocity at D, and the velocity from D to A. So, we know that the velocity of A to D, or D to A, I always forget which direction it goes in, but anyway, it's going to be angular velocity at D crossed with this distance, negative 5, that's given right here. That gives us 5 omega d I, and we know that, so we'll sub it in later. And we know the velocity at point 0. So we're going to sub in 6i plus 5 omega d I and solve. So that gives us 11i. So the velocity of A is 11 in the positive I direction. Now, we do need to figure out the distance of the rod. So, figure out this. This has an I component and a J component on that rod. So the rod AB, we know it's negative 5 is the drop here. And that is going to be plus the magnitude of this, which Pythagorean theorem, and we're going to solve for 14 squared plus 5 squared gives us 13.07 I. That's this distance from here to here in the I direction. Cool. So, because that's the hypotenuse. So, that is the y component of that, and that's the x component of that. So, now, we've already solved for our VA. Let's solve for our VB coming from the A direction. We know that the VB is the velocity of VA and velocity of B2A. So, we know it's going to be 11i, we solved here, omega b, k cross this term here, that's the rod, the radius of the rod, and that's going to give us both a j and an I component with both omega. So that's our first equation. Now we know that the velocity of E is going to be the velocity at q and the velocity of E2q, so that's going to be 0, and then that's going to equal omega k cross the radius distance, so that's going to be 6 omega I. And that will have a negative j component because remember we're going from E to Q, so that's going to be a negative j, and k cross negative j is going to be a positive I. So this term, VB, we know is going to be VE and VB2E. So VBE is going to be omega E, k cross 4j, because the distance here. So we know that's the distance, there we go. sorry, I. That should be I. That's not J. That's I. Because it's going to be horizontal. And K cross I. Let's do a check real quick. K cross I is positive J. Yep, that's correct. So now we can create a second equation. So we're going to sub these terms in, and we're going to have the velocity at B is equal to 6 omega E in the I and 4 omega E in the J, evidenced by this term here and this term here. Now, that's the velocity of B. Now, we also solve for the velocity up here. So what we do is we can equate the x components and the y components, or the I components and the J components, however you want to define it. So we're going to have 11I, 5 omega B, and we're going to have 6I, 6 omega EI. And we're going to have a J component here, and we're going to have a J component here. And so what we do is we're going to have two equations, two unknowns. We can solve for omega E or omega B. Omega E is 3.27 omega B. We're going to sub that back in to here, this upper term here, and solve for omega B. Omega B is 0.75 radians per second. We can take this term back in, solve it up here, drop it into this term, solve for omega E, 2.45 radians per second. So we have the velocity at E is going to be, again, omega E crossed with the radius that it's operating at. So the velocity at point E, if we go from above up here, let's see, where do we write it down? We'll do it right here. So velocity at point E is going to be E to Q, and that's going to be this negative term here for the radius, so, or 6 omega EI. So we cross that, and we're going to have 14.7 inches per second in the I direction. Okay. 15.8. So we have this diagram here. Arm ABC rotates with an angular velocity 40 inches per second counterclockwise. Gear B rotates 8 radians per second counterclockwise. Determine the instant center of the rotation of A and C and the angular velocities of A and C. Well, we're giving the angular velocity of B, 8 radians per second. We're given the angular velocity of the rod, 4 radians per second. So what we can do is, looking at gear B, if we notice here that the radius from B all the way to the center of A is 300, this radius here is 200, so the radius from here to the point of the edge of this gear is going to be 200, and the contact point here, if this radius is 200, is going to be 100. So we're going to set that up here. So it's going to be going 200 this direction, 100 this direction. This is going to be our V2, this will be our V1. Cross it, that's going to be our center point. What we're going to do is to figure out V2, we know it's going to be 0.2, that's 200 millimeters. 0.2 meters times 8 radians. That's the radius. So it's going to give us a magnitude of 1.6 for the velocity. Doing the same thing for this term here. It's going to give us a 0.8. Now, what we're going to do, we're going to save that for later. We're going to take A, so that's the velocity of B, we're looking for velocity of A and C, and the instant center, so we'll get to that. So let's take this term here, and what we're going to do is, again, that's going to have velocity term here, and velocity term there. That's for the arm, excuse me, for the entire arm here, and here. So we're going to have velocity in the B, velocity of A. The distance here is 300 and 300, so that's one direction, the other direction, and then the center is going to be here. We know it's 4 radians per second, so velocity A, velocity B is going to be pretty much the same. It's 1.2 radians per second. So now for gear A, we want to determine its instant center. So what we'll do is we'll take gear A, and we know from here as the velocity going down at its contact point, velocity going down with a magnitude of 1.6. Now, we also know that the velocity of A here, going from the rod, is 1.2. So, taking the difference in velocity, we know that our instant center is actually going to go to the left. So we're going to follow that to the left, and this term, this radius here, is unknown. But we do know its relation of omega r. So we can solve for that, divide velocity by r, and that gives us our omega. which is what we want is the angular velocity. So the angular velocity, we're going to take it as the difference in magnitudes divided by the radius of the gear. So that's going to give us 4 radians per second. And now we will take the magnitude of the velocity of A divided by the angular velocity, and that will give us the length to its instant center. So it'll be, we'll take this 1.2, velocity of A, 1.2, and the angular velocity of 4, and divide that, and it'll give us 3 meters. So the instant center is going to be to the left, 3 meters from the center. For gear C, it's going to be the exact same procedure. We've already determined the velocity of B and velocity at the contact point number 2. Then we know the magnitude is 0.8, magnitude of BV is 1.2, so that means that the center is going to go to the left. So the way we'll do that is that the term for length from the instant center is unknown. We'll take the difference in the magnitudes, divide by the radius, 0.2, and that gives us the angular velocity term at C, which is going to be 1.2 minus 0.8 divided by 0.2. It's going to be 2 radians per second. Now, what we're going to do is we take the magnitude of the velocity of B and divide that by the omega, angular velocity, and that gives us the length to the instant center, which 1.2 divided by 2 is going to be, that should be 0.6. 0.6 meters. That's not 6 meters, that's 0.6 meters. Okay. Now, try to check my terms now, I'm going a little crazy. Yep, okay, 0.6 meters. Excellent. So, or 600 millimeters. So, that is 15.8.